Welcome everyone to this explainer. Today we're unpacking a really massive topic, sustainable agriculture. And we're going to be looking at it from every angle, zooming all the way out to the global macro perspective, and then zooming right back into the micro realities of what's actually happening on the ground. Because honestly, it's time we move past the empty buzzwords and those shallow labels and really figure out how our food systems are structured.
Okay, let's dive right into this. Everything we're covering today, every data point, definition, and case study is pulled straight from this core academic source, the textbook Sustainable Agriculture and Food Supply. We'll be using it as our ultimate guide to navigate this whole complex puzzle.
But before we get into the heavy theories, I want to pose a question to you, just to get the wheels turning. In a world that is literally changing by the minute, both ecologically and socioeconomically, can anything truly remain sustainable indefinitely? Is absolute permanence just an illusion in a food system that's constantly evolving? Keep that in the back of your mind as we go through this.
To help us find some answers, here's our roadmap for today. First, defining sustainable agriculture. Second, localizing food systems. Third, organic farming realities. Fourth, biotechnology in agriculture. Fifth, climate-smart agriculture. And finally, building safe operating spaces.
Starting with Section 1, defining sustainable agriculture beyond shallow interventions. Obviously, we need to know what we're actually talking about before we can measure if it's working.
So, sustainable agriculture isn't just a random checklist of eco-friendly tasks. Academically, it's defined as integrated systems that satisfy human needs, enhance environmental quality, and sustain economic viability indefinitely. And that last part is absolutely crucial. It highlights the difference between shallow sustainability, just making short-term resource swaps, and deep sustainability, which literally forces us to rethink our entire system based on real, hard ecological limits.
And this brilliantly illustrates the clash between two totally different worlds. On one hand, you've got conventional farming. That's the industrial model. It relies heavily on massive capital investments, endless single crops, and a ton of chemical inputs. On the other hand, we have alternative food networks. These networks are trying to re-socialize how we produce food. They focus on spatial proximity, rebuilding actual social trust, and putting ecological functions first.
Which brings us to Section 2, localizing food systems, shortening the supply chain. This is where we look at how communities are actively trying to shrink the distance between the farm and your fork.
These alternative food networks, or AFNs, basically flip the script on economic power dynamics. By keeping things geographically close and selling directly to buyers, they completely cut out the middleman. The result? Fairer prices for everyone. But maybe even more importantly, instead of dealing with some faceless global corporation, this system builds actual mutual trust. Producers and consumers share knowledge directly. It's a full-on resistance to the massive distancing of the global agri-food industry.
Let's look at how this plays out in the real world with a case study from Cumbria in the UK. Their whole strategy was captured by the slogan, promoting local farms to local people. By setting up regional food hubs, farmers in Cumbria managed to bypass giant supermarket chains completely. And this was a massive win across the board. It kept money in the local economy, it built a real regional food culture, and it drastically slashed carbon emissions because the food didn't have to travel halfway across the country.
Moving on to Section 3, organic farming realities, measuring true impact. Because here's the thing, we need actual metrics. We have to be really careful not to just assume that anything slapped with an organic label is automatically perfectly sustainable.
Now, what's really interesting about this is how we can literally do the math on sustainability using something called emergy accounting. That's emergy with an M. If we look at a local organic vegetable box scheme in the UK, we can ask the hard questions. Is this farm running mostly on free local renewable stuff like sun, rain, and wind? Or is it secretly relying a ton on purchased inputs from the broader economy? Things like diesel, grid electricity, and external fertilizers. Emergy gives us the undeniable mathematical truth.
And the data from this specific study? Honestly, it's pretty surprising. You'd think the local organic box scheme would win hands down against a supermarket, right? Well, the research shows that while the local model definitely slashes transport emissions, it replaces heavy machinery with intense manual labor. And in emergy accounting, human labor represents a massive, massive amount of embodied energy from society. So ironically, the overall emerging flow from society actually increases in the local model. It's a wildly complex structural trade-off.
And that kind of tension is exactly what we see in this study on organic brain farming in the Canadian prairies.
The authors point out a really deep polarization. They note that, yeah, agricultural research and funding usually heavily favor high-tech, biotechnological approaches. But they also suggest there might be room for an ideological middle ground. It really highlights the constant friction we see between sticking to pure, strict organic ideologies and the pragmatic need for new, innovative agroecological solutions.
That friction leads perfectly into Section 4, Biotechnology in Agriculture, the debate over efficiency. This is arguably one of the most polarized debates in the entire food sector right now.
Looking at a study of the Swedish food supply chain, you can see two totally opposite camps laid out side by side. On the left, you have the productivist view. They argue that biotechnology is absolutely essential, like a fundamental requirement if we want the efficiency needed to secure the world's food supply long-term. But on the right, the alternative view pushes back completely. They advocate for agroecological methods designed to totally replace external inputs. These two groups just fundamentally disagree on what true sustainability even looks like.
Let's zoom back out to the global stage for Section 5, Climate-Smart Agriculture, Triple Win, or Empty Brand.
So the standard definition of climate-smart agriculture, or CSA, rests on three big pillars: sustainably increasing productivity, enhancing resilience to climate change, and reducing or removing greenhouse gas emissions. I mean, it sounds like the ultimate triple win on paper, right? But the crucial point the authors make is that this definition is incredibly broad. In fact, it's so broad that without some really strict metrics holding it accountable, almost any farming practice could twist the logic to brand itself as climate smart.
Because when you critically analyze the CSA framework, there are some pretty glaring gaps. For one, it totally ignores the brutal trade-offs that resource-poor farmers face on the ground. Think about it, you can't exactly ask a farmer who is facing immediate starvation to prioritize their carbon footprint over putting food on the table. Plus, obsessing over carbon metrics alone can actually lead to biodiversity loss. And finally, the research points out that CSA heavily targets developing countries, totally glossing over the fact that high-income nations have massive emission and security risks of their own.
Which brings us to the final part of our roadmap, Section 6, Building Safe Operating Spaces, the ultimate goal.
So what is a safe operating space? This isn't just another buzzword. It's a strict set of conditions that demonstrably proves with hard data that we are meeting human needs both right now and in the future without exceeding our local and planetary limits. Getting to true sustainability is going to take transformational governance and decisions grounded in transparent science. If we don't have that, we're literally risking ecosystem collapse.
Let's move to see how this builds into concrete, actionable steps. The text outlines 4 specific goals to create these safe spaces. Number 1, we have to slow the expansion of agriculture into sensitive natural ecosystems. Number 2, we need a massive increase in the efficiency of every single resource we use. Number 3, put a hard stop to unsustainable water and soil degradation. And number 4, fiercely protect biodiversity on agricultural lands. And the trick? We have to balance all of this while still feeding the world.
To wrap up today's explainer, I want to leave you with a really massive question to chew on. We are pouring huge amounts of time, money, and technology into agriculture worldwide. But how will we actually know if our collective investments are moving us closer to those safe operating spaces before we hit irreversible tipping points in our Earth and human systems? We have to constantly quantify and question our impact. I really hope you take that critical mindset into your future coursework. Thanks so much for joining me today.